Thank you for being here. Yeah, my name is Renato. I'd like to tell you my story with Amazon RDS and Amazon Aurora for well, about 13, 14 years now. That doesn't make me an expert of the service, just make me old. But yeah, things fall apart was actually the original title I had for this presentation when I initially was planning to submit to have it at reInvent. Somehow, surprisingly, Things Fall Apart was not really the title they wanted to have, so it was navigating Amazon RDS and Aurora for over a decade. That's the start of the story. Anyway, jokes apart, this is a presentation about how RDS, how managed relational database has changed in the last 10 years, 15 years, what you can learn now, what the mistakes I made in this journey, and how you can leverage and take advantage of the new features right now. So my journey so far, I said I've been playing with RDS for many years. RDS is one of the very first services from Amazon. I was very lucky when I started this. The post when Amazon announced RDS, that was 2009, so over 15 years now. And that was pretty much the entire blog post. There was, pretty simple service. There was not much to choose. In certain sense, I think it was much easier to be a cloud architect at that time, because once you had the constraint to work on the cloud, because either you had decided to do it or your employer decided for you, well, there were many limitations, but there was little you could do wrong. There was no many choices you could make yourself. Back in 2011, when I started, was, again, pretty simple. We'll see in a second what do I mean by simple, but quite funnily, people think I'm an expert of MySQL, or I love MySQL for certain specific reason. Actually, I used to love Postgres. I was working with Postgres until 2011 as my main database. I moved to MySQL because at that time was the only option I had to use Amazon as a managed database. And yeah, the other two things, well, at that time, once upon a time, was there were many more constraints. We see a few later on. And when we think about the whole time as good time, let's not forget that was a bit more expensive. We'll see those things later on. But why did I start my journey on Amazon RDS? Well, I was a Java developer. I was a backend engineer. I used to play with relational database. I was confident enough to run my own database on my machine or a single server or anything like that. But what about a cluster? What about replication? What about failovers? That was entirely out of my knowledge. And that was as well something that I didn't feel confident, or anyway, part of my job. So that was, for me, the main reasons to start to use Amazon as a service. As a database was, of course, was multi-Z, that was from 2010. So basically the ability to, I wouldn't say forget about your database, but the ability to have a database live where you don't have to manage yourself a failover, where you don't have to manage yourself the backup, or where you have at least a simple way to do a restore to point in time when something goes wrong. I said as well, the good time were actually not that good, because even without thinking how much the new instances are better than in the past, of course you cannot compare a, I don't know, M7G Graviton instance with M1, but still the real price that I cannot remember if that's for Northern Virginia or Ohio, but still the absolute price for the same instance size actually went significantly down over time. Something changed recently, but that's a bit out of the scope. Anyway, when I started, there was almost nothing that we have today. You are playing with, there was no GP2, GP3, there was no performance inside to monitor your database. You were playing with magnetic disk, that was it. There was just one engine. And of course, there was no Aurora, there was no provision, I hope. So, well, that was fun, but constrained. So, very first message of this presentation is a quite obvious one, is when you think that you go to reInvent or any big Amazon summit where there are big announcements, we all sit down and clap for 5 minutes for the new amazing service. We have to remember as well that that day is the day that your deployment might become a bit obsolete. I'm not saying it doesn't work anymore, but as a cloud architect, you should always optimize. Your goal, your job is to have the best cost-effective way to deploy your workload on the cloud. So that day that you are clapping for new announcement is possibly the day that you have something new to do, and what you have then in place in production is not the latest version, the best, or at least a reasonably optimized version. So I'm not saying change every month, but if you haven't changed your database, or that actually apply to any part of the cloud, but in the last 2-3 years, well, go back and take a look. Maybe there's something you're leaving on the table. So I'd like now to go to the central part of this presentation, is going through some cases, some mistakes I made, some lessons I learned over the way. I call them cases, but actually they are AWS cases, AWS support cases. And I think one of the main way I learn with managing a database on AWS was actually interacting with support through tickets or through chat or whatever. Some of these tickets were open with enterprise support, some with business support, some with actually developer support. And some actually were just tickets in repos or whatever for private account. But that's what I mean is you are not constrained just by the support level. Try to interact with AWS with support cases. These are just examples. The subject of the case is actually real. I just, of course, remove the case number. But the main message here is that, yeah, you can probably see from some example that some are bugs, some are production issue. I don't know, a replica broken after scale up, or I don't know, a snapshot that doesn't complete. Those, okay, are typical cases. But what I would like to encourage you to do is try to always validate your changes to a database, because I mean almost all a database, because a change to a database, the API call might take milliseconds. But the change to your storage, the change to your cluster might take literally hours or even days to be warm and be ready to serve properly your production traffic. So maybe validate your assumption. It doesn't mean give your job to AWS support and just say, how can I do that? It's just, maybe you have an idea, maybe you want to use, I don't know, blue-green to do a change to the production database, to change the engine or to do something, but you have a question about a parameter, about a constraint. Just describe your case and ask if that's the best way to go, or if they have any advice. Most of the time you get some advice, some reasonable feedback. And the second case I strongly suggest that is when you have a limitation. Some of those cases are kind of asking for feature. Like, I don't know, bin long transaction compression is not supported on the multi-AZ, the standard multi-AZ. Of course, you can ask to have it. Maybe one day you'll get it. But as well, ask for advice how you can go around that, if there are other ways to optimize or to minimize your binary log or whatever you're trying to achieve. Anyway, let's go through some challenges as well, some solution I had in this journey. So one question I always have is, I've been really struggling with RDS, and one, to me, big benefits of Aurora is, of course, is allocated storage. You pay for storage. With Aurora, I'm simplifying a bit, but with Aurora, you pay the storage you really use. With RDS, you allocate the storage and you pay for the allocated storage. So you have to decide how much storage you need on your production database. There are ways to scale it up automatically now, but it's still a not transparent process. I mean, when you reach certain threshold, it has a specific percentage of your storage, so your storage grows in kind of steps. That's cool. How do you reduce the storage if you need to reduce it? That's a bit more challenging. There's a way now with blue-green approaches. We'll see the advantage and the disadvantage of that in a second. But usually it's not that simple. This is a production database I'm managing that has, at some point, even had about 2 terabytes of free storage. You might say, well, that's pretty much free storage for production database. You are paying, giving away money for free. But why did I have that? What went wrong, or why did I have that in place? Well, actually, it's pretty hard to predict as well how much storage you need for operation. And this is one of the mistakes I did, a rookie mistake I did a few times, is do operational changes to my production database with some kind of auto-scaling in place on the database. So let's say you optimize a table that is, for who is coming from Postgres, I wouldn't call it similar to vacuum, but yeah, it's the idea that you're trying to, and we'll see in a second why we want to do that, we try to reallocate the data inside the table, or you just modify a large table, you want to add, I don't know, a column, something you cannot do with a simple instant change and requires a copy of your data. Well, how much free storage you need on your database? Well, it depends. It's at least probably now as much data as you had, maybe a bit less because it's better reallocated, but as well there's the binary log, there's the transaction, who knows? Well, one mistake that happened a few times to me, actually 2-3 times, was to forget that I have elasticity in place, so the storage goes up. But when that storage goes up, it's the worst time it can happen, because you actually think if you're doing operations like an alter table or anything significant on your database, the last thing you want is that some activity on the AWS side is going to eat your IOPS or mess around with your data. So first lesson I learned the hard way was to disable any autoscaling or have actually protection in place that is mostly alarms on the operation I'm doing and how much storage I'm going to need. But how, and that's one of the power to me of the cloud, and here I did as many mistakes as possible, is how do you actually modify a table on RDS or Aurora? Well, this is an example of an InnoDB table that applies to anyone. Well, the how can be many ways. You can do an alter table with your engine. So you say alter table, whatever. You can use a third-party tool, an open source tool like Percona Toolkit or whatever, where you do it maybe in a more controlled way. It might take longer, but you affect less the production load. It copies the data in chunks. You can recover it. It's up to you. One is simpler, the other one is harder, whatever. But the where is, to me, is the real power of the cloud, because, well, I can do the alter table on my primary node of my cluster, hope for the best. If it's a small change, if I don't lock too much, maybe it works, and I cross my finger and hope for the best. That's the way you will do it, probably. But you can do it on a replica. If the operation allowed to do an replica, think about adding columns, for example. You might want to promote the replica from read-only to a writable one, do the change, and then the power of the cloud is that you can swap the names of the endpoints, and that's the magic. You have your new production database, and that's it. Or you can use something that Amazon now provides, that is RDS blue-green. That is, I will call it a wrapper from around doing yourself some kind of promotion of a replica cluster, but that's up to you which way you do it. But that's an example of my free storage on that database, how it changed over time. Well, there was, at that point, over 1 terabyte of free storage, but what happens here, that you probably don't see very well, is at the lower point, it goes down to 0. So what happened at that point was, well, my database crashed. That's not much fun. But why did I want to do, for example, that optimize database? Well, according to the documentation as well, backups are free, kind of. Sort of. You pay for backup for snapshots, but according to the documentation from day one is most customers will never pay for backup storage. I'm not saying that AWS is lying here, but there are some constraints there. They are assuming that you don't keep many days of backup, probably 1 or 2, not 30 or 35, and because they're incremental backups. And as well, they're assuming you don't have much write on the database. Otherwise, it's very unlikely you're not going to pay. So let's see what happens when you pay. Well, that to me was the very second lesson I had is I used to talk as well a lot at conference with people and discuss a lot engines, which class of the database I'm using. Is a Graviton one, is a Intel one, or am I using M5, M6, or C, or memory optimized, or whatever. And actually, what I realized over time is that this is an example of a production database. These are monthly costs over 3 years. There's a significant growth on CPU cost. That's using reserve instances. And that's a healthy database. The database, the cost is growing because the project is successful. There's a natural growth on the number of users. That's fine. But even storage and almost all backups grow to the point that the cost of your CPU is, at least in this example, is even less than 50% of your overall cost of the database. So always think of the overall cost of the database. And backups is one that I hardly hear people talking about. Storage, sometime. And we see example in a second of major problem with storage. CPU is usually the main thing we love to discuss, but I'm not saying it doesn't count, but it might not be your main problem. And that's an example of a free cost of a backup being free. This is the cost of, about the growth of the usage of backup. And that's why I was doing those optimize. Because, yeah, I mean, if you think that backup on relational database is done at the EBS volume, because behind you have those EBS volume, at least on RDS, the way it's done is done at the disk level, is not a dump of your data. And it's done incrementally. So if your data is spread around, you do a lot of write around your disk, that's very likely that your daily incremental, something you don't see through the API, but you can ask AWS support to have some metrics, might be quite significant. Now, I think in this room you're all familiar with Chloroquine. That's a tweet he put out when the very first Graviton instance for RDS was out. And it's provocative, but I think he has a fair point. I mean, you're using a managed database. Why do you care about if it's a Graviton or Intel or whatever else? Actually, I want to just, I mean, why do I care about the processor? I might care about how many CPU, how much memory I have, but why should I care about the specific of the processor? Well, at that time, when it happened, that's another failure I had, I was running kind of a autoscaling of my database. That was before having a real serverless database. So the idea was, let's do at least some vertical scaling. And the idea was, use some metrics. You can do it easily. You can just use CloudWatch. You monitor certain metrics. And then you can use either the command line and do your own bash script or Python or whatever you want to use, or just write a Lambda function that periodically check those alarms, or just event-driven on those alarms, and scales up and down your node. That's just vertical, is doubling or halving the instance size, but yeah, that's the best you could do at the time. But what went wrong? Well, that's what I ended up having, a crash. And that's a crash of the instance. Well, that's a bug. But what was the problem I had? What was the real root cause? It was not that really that was buggy. And of course it's very easy. I was an early adopter of Graviton, because if you use a managed service, it's just a click of a button or an API call. You don't have to build your own stuff for Graviton. You just use it. It crashed, so it's a bug. Is my problem? Well, actually, it was my problem, because what happened was that I was trying to over-optimize my parameter group, try to decide to don't leave anything on the table, increase a bit, for example, the buffer pool size, because I didn't like to have free memory. I didn't like to have, basically leave money on the table for Amazon. So yeah, I thought to know it better, to over-optimize, to be a non-database administrator doing the database administrator stuff. What happened is my auto-scaling logic was not working anymore. My database was crashing well before reaching even 80% of memory, of CPU usage on Graviton. The reason was pretty simple. If you are familiar, I'm sure you're all familiar with it, is the ratio between memory and number of CPU is different in Graviton and Intel. So at that point, all my logic was broken. And if I had kept the default parameter group, most of the default option, that would have not happened. So hard lesson, learned in the hard way. So, okay, you move to Aurora. So you decide, okay, I have my RDS and I want to move to Aurora. That's cool. So takes 15 minutes, no, 10 to 20 minutes, less than $1 to learn how to migrate without any downtime to Aurora. That's according to Amazon. And that's true. It's basically, they tell you, you create a read rep, you take your RDS instance, you create a replica as an Aurora replica, and then you promote that replica. That's actually, it might take much longer than 15 minutes to be ready to serve traffic, but the concept is pretty simple. Well, that's what happens to me multiple times. You try to create that replica, and Aurora tells you, I cannot create your replica. And the reason is a bit trickier, is the way Amazon handles databases. You have to think that a three-step process. There's the open source version released by well, for MySQL is released by Oracle, then there's Postgres, but a similar concept that is released day one. So day one, there's 8.0.39 release of MySQL. Usually, Oracle release one minor every quarter. After a few weeks, best case 6 weeks, worst case a couple of months, Amazon start to support that minor version on RDS. So the community edition, that minor is supported on RDS. But it takes a much longer period before that minor is supported in the Aurora fork. Usually at least another 2-3 quarters. And not every minor, it might jump a couple of them. The big problem is that you can create an Aurora replica only if that minor, you cannot have that the engine of the replica is older than the primary. So basically, if I try to keep myself up to the very latest version on RDS, I'm most likely not able to jump on Aurora. Unless, okay, I can do a dump of all my data and import on a new Aurora. That's not without downtime. So lesson learned the hard way is either you keep yourself a bit behind, so just try to stay behind the latest minor, or keep in mind that the easy option to jump to Aurora when your load is greater and you want to have a kind of exit strategy from RDS, it might not be there for quite some time. So I used to write a lot on my blog. I haven't done it for quite some time, but still after now it's what, 7 years? This post is the most popular post I ever had, and is still one of the most popular. Even if that content is absolutely rubbish, is now old and doesn't apply anymore, but because it's a common problem. People tend to underestimate the challenge of managing IOPS on RDS. And running out of IOPS is something that happened to me, I don't know, many times. And what do we mean by running out of IOPS? It means that your database is underperforming. Because we tend to forget that, for example, GP2 and GP3 doesn't guarantee, I don't know, 4.9 of the target IOPS, but is 99%. So you think how much time you might not have those performance. And how do you measure it? Well, there's a total IOPS metric that has been there for a few years. That didn't used to be there. Keep that one in mind, but what's the value? Well, GP3 is usually better than GP2. I mean, as idea is GP3 has a fixed number of IOPS by default, that is 12,000 for above 400 gigabyte, I'm trying to remember by mind, on RDS, while GP2 used to have just a number of IOPS that was a multiplier on the disk size. So if you have it was 3 IOPS for every gigabyte of allocated storage. So up to 4 terabytes of storage, usually GP3 provides you more IOPS by default at the same price than GP2. Above, you might have a point to use GP2, but reality is GP3 is more flexible because GP3, you can still change paying the number of IOPS and the throughput for your disk at any given time. You cannot do that on GP2, so stick to that. Do not use IO1 unless you really have to. Use IO2 because IO2 has now been out for 1 year and provide more or less, I will really say, double performances on IO1 for most use cases. And the key feature equals the same. The price of IO2 expressed compared to IO1 is identical. Now, another lesson is that I learned the hard way is, yeah, IO2 and provision IOPS is something that you get almost by default now when you go and create a database from the console. When you say production, you get all those ticked boxes, including having provision IOPS and whatever. Is that provision IOPS better than GP2? Is IO2 volume better than GP3 volume? Yes, definitely it's better, but it's incredibly more expensive. So it's up to you as a cloud engineer to figure out if you really need it. There are scenarios where you need it, but often you should see it as a temporary thing. Maybe it's time to do some sharding. Maybe it's time to think about a different solution. If you consistently need on a large database and you need to keep increasing the provision IOPS as an absolute number on a single instance usually is a sign that something is going the wrong way. A mistake, unfortunately, I did a few times was if you use IOP 2 or I1 as well, remember that any replica, copy of your data, restore from a backup, staging you create from the production is going to have that storage. And that's a pretty expensive storage to have to give to your development team to play around. Blue-green, called blue-green and purple, this is a graph from, that was a recent one from Performance Insight. And I was surprised that I had no data before August 25th, and the data between for 4 days was not that significant, let's put it this way. And there was no data before August 25th. So I checked the documentation. I just did that day a blue-green deployment. So, well, according to the documentation is blue-green is a copy. They create a copy, and the feature include of your cluster. So you have the same replica, the same storage configuration, same snapshot, same automatic backup, same performance inside, same enhanced monitoring. Well, what they actually mean is you have the same performance inside configuration, not that they carry your data over when you do the blue-green. And yes, support confirms that. So when you do a blue-green, you're basically switching from your old cluster to the new cluster, keeping the same name. I'm simplifying a bit, but that's the idea. At some point, you will delete the old one because you don't want to keep live those two clusters. Well, the moment you delete that one, you're losing all your previous data on performance inside. Is that a problem? Well, it depends. I mean, there are scenarios where you really need to do a major upgrade and you need blue-green, and that is not it's a pity. You might export your data using the API and do some tricks, but do it for every minor release upgrade. Well, balance out if it's worth or not. You might not care about performance inside, but that's, to me, was a critical thing, for example, to lose the 2 years of data of performance inside just for a blue-green. That doesn't apply to CloudWatch because, well, in a weird way, performance inside used the ID of the database and of the cluster, and that changed. CloudWatch used the name, the RN, and that doesn't change. Go and figure it out. But the main lesson I've learned in these years is that I always underestimate the time it takes to make a change in a production database, almost all on RDS. Let's say I create a replica, and I say I want to do my alter table on a replica. Well, I create my replica, and after probably 20, 30 minutes, my console or my command line or API, whatever you use, it's going to tell you, you go from modifying to available. So you think, well, it's green, it's there. And technically, it's there. But the key point is that you're not just copying an instance, you're copying storage. And that storage is actually a snapshot coming from S3, and that snapshot is cold. So what happens is you now have your replica that starts, but the replica, if your production database has some reasonable load, cannot keep up at the beginning with the database, with the primary. So what happens is the replica lag grows, and this is an example where the replica lag increases up to 80,000 seconds, and that's 80,000 seconds, quite a lot. The size of the replica was the same size of the instance. Think about that. I could have provisioned a better instance, I could have provisioned a better storage for the replica, but you cannot change it at the point. That's what you have. So in that case, it took me days before actually being able to do anything on that replica. So that's the lesson. And if you actually do instead with blue-green, they fixed it a bit now. If you do blue-green, there's an option now to say, I want to warm up my storage before it was not there. Well, take it. It's going to take some time extra, but if you don't do it, that's what happens when you do a failover. It's not a failover, it's, a blue-green, you replace the blue with the green. That was my production database. That's the disk queue depth. That means that for a few hours, 4 hours, basically my production database was struggling. The load was significant. The queue depth exploded. And the worst part for me was that I couldn't do anything about that. databases that any change I'm going to do is going to make it worse. So that's the thing. Still have a few minutes to do some, what I would call super simple experiments. And what I mean here is just to try to address a common question I had in this year playing with both Aurora and RDS and any other database on Amazon is, what is faster, what is better? And usually the answer is, it depends. It depends on your use case. There's a default reason to move to Aurora. No, there's a default reason to stay on RDS. No, there's a reason to go to limitless now or to, well, it really depends on your use case. As I said at the beginning, the life of a cloud architect was much easier in that sense years ago. Now there are many options and you have to balance really as a bit as with blue-green, you have to decide. I'm not saying there are no benefits, there are big benefits, but as well some drawbacks. Your job is to try to balance for your specific scenario if the drawbacks that often are not that visible are that significant for you. Anyway, let's say you want to do a simple benchmark. I wouldn't even call it benchmark. Let's say you want to compare Aurora with RDS. Maybe, as I often had that question, that MariaDB is better than MySQL, whatever it is, what the company was. And I thought, how can I do a very simple setup? Well, I took RDS, I took a 400 gigabyte storage, that is the minimum to have 12,000 IOPS. And the smallest instance I could have that was reasonable, that I could afford with my credits. And I did a similar setup in Aurora. Those were the two instances that I used. And I decided that my goal was very simple, to insert 100,000 records. Nothing major, but one at a time in a single thread, because of course we've...
Thank you, Renato. We have time for just one question. No questions? Okay, one from Dima. Thank you, Dima.
So I would like to thank you first of all, since even if I missed the piece because of the photos, thank you very much. It actually reminded me my journey when I was also doing almost the same research, comparing different instances, also including the storage, because we had an interesting situation. We were running the smallest possible one of the databases in the production, and it was swapping, and swapping was exhausting GP2 credits, and then the whole DB instance was not productive because we ran out of everything. So I really love GP2 drives, and yeah. So my question is, for example, you did the comparison between the Aurora and normal RDS, but what is your perspective on the serverless Aurora? Is there any big performance difference or not really?
Okay, in this, what I call silly experiments, there's no big difference with Aurora serverless. I mean, there's just one main difference is, if you do the very same test with Aurora serverless, it really depends what's the minimum starting point you have. If you start, well, apart from starting at 0, even if you start at half ACU, you won't finish in 2.9 seconds. You'll see that it's probably going to take, I don't know, 4, 5, the 30. The second run, if you do it immediately after, of course, you go down. That's for the very same reason that it takes time to allocate, to anyway scale that up. In terms of storage and usage, actually, I use a lot the V2 now. It really depends on the use case as often. One thing I learned the hard way was, for example, that I was running some KPI on replica. I was creating, let's say at midnight and every Sunday or every first day of the month, a copy of my, taking the snapshot and run some analytics on that instance at fixed time. And what I realized that my idea of saving money, for example, in that case, to keep a small instance, because yeah, it's just my analytics. Why do I want to not affecting use data? It's better to try to save money there. Then I realized that actually the most effective way was to use a large instance with a very optimized storage layer, because actually the time that takes to run the analytics was the most significant part, and the storage was the most, the cost component, yeah. So it really depends on what you're trying to achieve with your instance. About 5 terabytes of data. Sorry. Yeah. 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 The only advantage of GP3 is that you can still save yourself in the short term, changing a bit the IOPS. It's not going to affect immediately, but it's better than nothing. You have at least